Hello programmers, welcome to the today's Leetcode daily challenge. Today we will be solving day 7 of this, and today's question is avoid flood in city. Okay, let's directly jump into the problem. Okay, let's now understand the problem, what it is saying. Your country has an infinite number of lakes. Okay, so there will be some lakes. Okay, I will mark lakes and like ponds, some lakes here. Initially all the lakes are empty. Okay, but it rains over the nth lake. Okay, this is like nth lake, and the nth lake becomes full of water. Okay, whenever rains on this lake, this will become full. Okay, if it rains over the lake that is full of water, there will flood. Okay, so if it is full and there is more rain, more water coming to it, obviously there is a flood. Okay, and your goal is to avoid floods in any lake. Okay, so we have to avoid this flooding. We don't want to die with flood, so we want to avoid the flooding. We are the engineers here. Given an integer array range, okay, where range of I greater than 0 means if it value is positive, then it means that there will be range over range of I lake. Okay, so there is a range of array given, and what range of I present, that lake number. Okay, so if range of I equal to, let's say, 5, means fifth lake, it will be running on the fifth lake today. Okay, so we want to make sure that this fifth lake will be empty before raining. If it rains over that full, then it will be a flood. Okay, somehow we have to empty that, or it's empty at the start. Okay, rains equal 0 means there is no rains on this day, so you can choose one lake this day and dry it. Okay, so there is no, okay, it's a dry day basically. If value is 0 means you don't have to rain on any of these lakes, so it's a dry day, so we have to dry any of the rain. Okay, one lake, we choose one lake, any one lake, and we will dry it. Okay, return an array answer where answer of length range equal to length. Okay, same length का इनको आंसर चाहिए. Answer of I equal -1 if range I equal to 0. Okay, if it's raining on the day, we will answer -1. We can't do anything, right? And answer of I is the lake you choose to dry in the ith day if range of I equal 0. Okay, so if it is 0, then we will choose which lake to dry on that day. Okay, so let's say we choose nth lake, so we will put n here. Okay, if there is multiple valid answer written any of them, it is possible to avoid flood in any empty day. Okay, okay, if it is impossible to avoid flood. Okay, okay, let's say I have given input as की fifth पे rain होगी, then fifth पे होगी, so this is a fifth lake and there will be rain, then rain, so it will be flood. Okay, first rain it will become full, and on the second rain it will be flood there. Okay, okay, so basically we have to avoid this situation. If that's the case, then we have to return the empty array. Okay, got it. So let me remove these drawings. Notice that if you are choose to dry a full lake, it becomes empty, but if you choose to dry an empty lake, nothing changes. Okay, that's a good piece of information here. So if we choose a full lake, then it will become empty because we are drying it. If there is already a dry lake, this is a dry lake, and we dry it again, nothing happens. Okay, so let's take a look at inputs. So we have given some rains 1 2 3 4. Okay, so there is a rain on first lake 1, this will be rain on second lake, third lake, and fourth lake. So we got to know that we have 4 lakes, and day 1 here, day 2 here, day 3 here, day 4 here, all will become full, nothing, all will be happy, we have lots of water here, so we will return answer -1 -1 -1 -1. We don't have to do anything for this example. Okay, this is clear, I hope. For second example, it is saying it will be rain on first lake, so this is a lake number 1, and it will become full. On the second lake, so it's a lake number 2, it will become full. Then there is a dry day, then there is a dry day, then there is a second lake, which will become full. Okay, then there is a first leg which will become full. Okay, so these legs are like we don't have to draw. So again we have a rain on second leg, and again we have a rain on first leg. So obviously if double, it's already full and we will be having one more rain, so we have to dry it. So we will dry it on one dry, and we will dry the second of the leg on the another dry day. So we have two dry days, we will dry both of them. Okay, then in example number 3, 1 2 0 1 2. Okay, so we have rain on first leg, then we have rain on second leg, then we will dry. So let's choose anyone, let's choose second. Okay, we dried the second leg, so it's not in the picture now. Then it's raining on first. Okay, so let's dry first. Okay, so first, second, on the dry day I am choosing the first to dry. So now first not in the picture, now it's raining on first. Okay, 1 will become full, 2 will become full, now it's 2. Okay, so on the 2 we aren't able to dry it, so answer will become like empty array. Got it. So how to approach this problem? Can we get some help from the constraints? Constraint 10 to the power 5, 10 to the power 9 means it's a long constraint. Okay. Okay, so I'm thinking of something like, if I do, let me check my color first. So if I have some rainy days, we have cluster of rainy days. Let's see, rainy days. Okay, then we have cluster of some dry days. Okay, it can be cluster of 1, cluster of 0. After that we have a rainy days, rains, and then we have a dry, something like that. Okay, then rains again. So rain, dry, rain, something like that. We have a layout. On the dry days we have to choose which leg to dry it. On the dry day we have to choose which leg to dry. Okay, that. So if it is rains on some lake, let's make it some lake X. We have a X. If it's raining on X, some lake X, and it's raining again in future, if it is raining on the same lake X, if we find that okay, it will be rain, there will be rain on X, then obviously we have to dry it. Obviously we have to dry it. So in one of the dry days we will dry it. Okay, so before this rains, we have to dry it. We have to make sure we are able to dry it. If we are not able to dry it, then we will return empty array that we are not able to dry it, and there will be flood. We can't avoid any flood. If there will be a flood, we will return the empty array. Okay, got it. So let's make a custom example. For example, we have a rain on lake number 2, lake number 1. Let's take lake number 5, and let's take lake number dry day 0, then flood on lake number 1, then 0, then 2, then 0, then 5, something like that. This is our input. It's custom made by me. So this is our input. Okay, so this is our input array. Got it. Okay, so we will go through this, we will iterate, and we will check. Okay, so we will check that 2 first, second leg we come, and we say that okay, second leg we have full, so we will mark it as like full. Second leg is full. Okay, now first leg, it's rain, we will mark first leg as full. Okay, first leg at full. Okay, then we will check it fifth leg, and we will check fifth leg is full. Okay, then there is a dry day. So we have a luxury to empty any of the array, but we don't know yet which of them to empty. which of them has a highest priority to be emptied. Okay, we have to give some priority, like whom to empty, like which leg to choose to try it, so it will be beneficial for us in the future. We haven't seen next rainy days till now, so we can't predict anything now. We will cross the bridge when it comes. Okay, now we are moving to here at 1. Okay, so we found one, that we have to try some lake. Obviously here I find that we have to try some lake. Okay, got it. So we will try it. So we will mark this lake as empty now. It's empty lake now. It's empty lake now. On the this day, on 0th day, whatever 0 came between these two, whatever 0 came, we will try. We will make sure that it will be marked as 1. So in answer array, we have all the minus ones, minus 1, minus 1, minus 1, 4, 3. But for this 0, there will be 1. We will try leg number 1 on the day, then minus 1, something is there, 2, something will be there, and 5. My bad, not 2, 5. It will be minus 1, minus 1. On whatever day we have a rain, we will make sure it will be minus 1, and if there is no rain, we will make sure that if there should be some lake to choose and try it. Okay, then at this 0, we are still pending here, like this answer is not marked yet. At this 2, we will check. Okay, we have to check if 2 is full. Yes, 2 is full. If 2 is full, then we have to mark it as empty. Okay, so we will mark it as empty, and we will point to this, and we will say we will try second leg on that day. Okay, so we have to find a dry day between these two, right? Some dry day between these two, or only this dry day was remaining. Okay, then we will come to 0, then we will come to 5. Okay, when we are coming to 5, that means we have to dry some leg, because 5 is full. We will check for 5. 5 is full, 5 is already full, so we have to dry. So we have to find some 0 in between them, these 5 to these 5, that we have to dry this leg. Okay, so my bad. So let's remove this. We will make sure that this will be propagated to here. We will choose leg number 5 to dry it, and we will mark this leg as empty, and we will move ahead, and done. We are done. Okay, let's take example. Let's take, we have one more one here. Now it's raining on 1, leg number 1 again. Okay, so we will check leg 1 is empty. Okay, so we mark it as full because it's raining, so it will become full. Okay, let's check. Now it will be raining on day number 5 again. So 5 is empty. No, 5 is full now. My bad. 1 is also full. Correct. After the second rains, each of them will become full now. I will explain you in 1 minute. Okay, so at this index of 2, let's take example of leg number 2. Let me change the color first. Okay, at this index, at this point 2, we have a full leg. Like leg number 2 is full. Then we have dried somewhere in between. We have dried it here we have dried it. So leg number 2 is empty now. Then again it's full. Here. And again, if this 2 comes here, so we have to find a lake between these two indexes, like this day and this day. Between these 2 days, we have to find a dry day. To dry this leg number 2, because it's full. We have to mark it full again. So we have to dry it somewhere in between. Okay, between these 2 indices, I have to dry it. Okay, and if it is, we found a dry day, but it's already taken by 5. It's already taken by 5. So we don't have any more dry day, and we will say that we will surely be flooded our city, our country. Okay. So for each occurrence, we need to find the first date. What's the previous occurrence of that, and what location? Okay, that's the location. At what location we have a previous occurrence, at what location we have a current occurrence, and between these two, if there is any dry day, we have to track of, we have to iterate basically, and we have to find that how many dry days is there in between these two. And if it is not taken, then we will not check that. If it is not taken, if answer is like still -1, then we will dry it. Okay, we will make our answer is right. Okay. Makes sense. But this will take like logarithmic time, n square time, and this algorithm is brute force algorithm, and it will take n square time, since we are making sure that we are iterating between these areas. Okay, we are iterating between these, then we will be iterating between these two ones, then we will be iterating between these two 5s. Okay, so for each index we are iterating some of the length, so we can say it's order of n square algorithm. We have to optimize it. Can we optimize this finding wala part? So is easy. We have to optimize this. We have to optimize this iteration wala part. Okay, we have to optimize this iteration wala part. How to optimize this iteration? We have to find. We don't have to iterate. We just have to find the zeros. Okay, at what location 0 is. 0 is at what index? Okay, at what index we have a 0. So if we pre-process this array and find all the zeros and store it in a array, we can do binary search on that array. Yeah, sure. And we can find in logarithmic time that between this I index, between this j index, if there is an index which has the 0, we can find easily. Yeah, sure. And after that we will fill it. Mark it fill. Mark as fill. If it is marked as fill, then so done. We will remove the 0. Okay, we have to remove also now. So from array we can't remove. If we are removing the array, then it's all, each removal operation will become often, and it will be a big problem for us. Okay. So for that reason, can we use another data structure which array is providing us the sorted string, right? Sorted, and it is providing us the binary search in log n time. So what to expect now? We have another data structure which do this. We have a set. We have a sorted set. So sorted set, what it does? It provides us the binary search. It also keeps the elements sorted, and we can remove the elements in log n time. Nice. So it will solve our purpose, right? So let's revise once. What we will do? We have in our example, beautiful example, 2 1 5 0 1 0 2 0 5. Okay, let's take this example again, and let's run on this, the algorithm we have designed. Okay, so we will keep a track of where we have seen 2. So we have seen 2 at location number 0. This is index 0, index 1, index 2nd, 3rd index, 4 5 6 7 8. We have 8 indexes. We will track of 2 is seen at location 0. This 1 is seen at location number 1. This 5 is seen at location number 2. 0 we will ignore. So for 0 we will do some pre-processing, right? Pre-processing. So let's do some pre-processing. We will make a set of these indices. Okay, we have indices at 3 So we have 0, 3, we have 5, and we have 7. At these 3 locations we have zeros. Okay, so we have make a set to mark all the indices where we have a dry day. Okay, now we will come to here, we will do nothing, we will come to here. Okay, whenever we are coming at 4, whenever we are coming at this location, we found that 1 is already present in our data structure. Some data structure is this, our group of, we have already seen 1 somewhere, and it's at index 1. Okay, so we have to try it before filling this. If we are not able to write, then there will be flood. Okay, so at index 4 we are at currently, this is I, this is the previous index we have seen. So between this previous index and between this I, okay, do we have any set element, do we have any of the 0, any of the dry day, then we are able to proceed. Okay, so yes, previous is 1, current index is 4. Do we have any dry day between 1 and 4? Yes, there is a dry day number 3. On the third day it's a dry day, so we can we can mark this answer of this dry day, means answer of 3 as which leg to choose. We are choosing the leg number 1. Leg number 1 we will try it. We will try the leg number 1 here, and we will update the location that last we have seen 1 at 4th day. So this lake 1 is filled with water on 4th day now, because it's empty on 3rd day, we have dried it, and on 4th day it will again fill up. Got it. Let's move ahead. On the day 5 we have a dry day. Also we have to remove this from the set. We have to remove this from the set because it's now not longer available. This is taken, this dry day is taken care by this lake number 1. We have already chosen for this. Destiny of this we have already chosen, so we don't have to store it. We can remove it easily. Okay, now we will go to 6th location, 6th index. There is a 2. Okay, have we seen 2? Yes, we have seen 2. We have seen 2. Where? We have seen at location number 0. Location number 0 we have seen. So we have a previous location at 0. We have a current location at 6. We have to find a dry day. We have to find a dry day in this set. We have to find a dry day that exist. Yes, there is exist 5. So we choose day 5 and we mark it as, so 5th day is which leg to choose? Leg number 2. Leg number 2 we are choosing. This is leg number, and we are drawing leg number 2 on the 5th day. Great. Okay, now we will update the location that on day 0 leg number 2 is filled. On day 5 leg number 2 is empty. On day 6 leg number 2 is already filled again, so we will mark it as updated at 6. Last we have seen at 6. Let's move ahead. 0 we have to skip, no action needed. 8, what to do? Now we have 8. Okay, so if we have 8 location, 8 day, we have to see that if 5 is empty or not. Now 5 is not empty, 5 is already filled. On day 2 we have filled the 5 here. Okay, so we have to find a dry day between this 2nd day and this 8th day to dry my leg. Okay, so we will find from 2 to 8. This 5 is already taken. Okay, we have 7. Okay, on day 7 we have chosen the leg number 5 to be dry. Okay, and that's our answer. Other location of answer will be like -1 because it's raining on that day. Great. So let's quickly implement this algorithm. Let me take this size. Okay, and we will take a set. Okay, set of indexes of, let's mark it like 0 indexes where 0 present. Okay, and we will do pre-processing step. So this is pre-process the array. We will iterate over the array, and we will check if range of I is 0, means it's a dry day now. Then we will we will insert this index at in 0 index array. Okay, this is pre-processing done. Okay, now we have to mark, we have to create a data structure. So I'm thinking of a map. So map will take care of key, is this element present in this map, and if there is a element, at what location we have seen it before. Okay, so I am creating an unordered map, of and map simply. Okay, so what it stores element or rainy day, basically lake number and index. It is storing lake number and last seen index. Okay, it is storing these two things. Okay, so also we have to define our vector of answer, right? Answer is n size. Okay, and let's fill it with -1 to start with. Okay, so now we will iterate over the array simply. Okay, plus we will iterate over the array. We find if it's a rainy day, then we have to do something, else we don't have to do anything, we will skip that. Okay, got it. If it's a rainy day, what to do? If it is a rainy day, we will check if we find this rainy day in this map, if the lake is full or not. Okay, to find, so we will do map.find. What element to find? Range of I. So there is two condition, this can reach to map.end. This iterator will be at the end. So if there is the case, else the case, there will be two cases. Okay, we find this element, we don't find this element. Okay, so this is the case of not finding. Okay, this not equal to map.ends means we found it. Okay, so found it, here we will say that not found map. If not found, then it's simple, we just have to insert range of I is seen at location number I. Khel khatam, that's it. Okay, if we found in the map, now look at this. If we found that rain is already there, like this lake number is already filled. Okay, range of I gives us the lake number. If this lake is already filled and it previous location, so we find that int previous location is map of range of I. Okay, so this is our previous location now. Okay, we find the previous location, we have the current location is I, and we will check that if we have any 0 in between them. Okay, we will check. How to check? It's simple. We can make it iterator, auto iterator of this 0 index set dot do upper bound. Okay, of previous location. So what upper bound does? Upper bound is doing like just greater than this previous location. We want a first element which is greater than the previous location. That's what we want. Okay, so there is two cases, we found, we don't found. Okay, so let's say if we found it, so our iterator not equal to goes to 0 index dot end. Basically we found it, and else condition we don't find it. If we are not able to find any of the 0 to try this lake, obviously we will return directly from here that we are not able to find any of the solution and lake will be flooded. We can't stop flood, we will return the empty array from here. Okay, now we found it in the 0 index, and then we have to check that this lower bound. Okay, so how to check? And index will be like star of iterator. So let's do this. Star of iterator should be less than our current I. Okay, if it is not current I, less than current I, let's say we found upper bound which is too big, and now we are sitting close enough. Okay, so ranges are close enough, in between them there is no dry day. We found an upper bound of the lower location which is too big, so it's not useless, it's useless now, so we can't stop the flood, right? So we should check that we actually find it, and we find it between these two. So from upper bound we have make sure that it's greater than previous location, and from checking this condition it should be less than I. We found that it's between these two. Okay, previous location and current location. Correct. Okay, if we found it, then let's take an index. Let's make an index. What to do with this index? First of all, we will fill this index with our range of I, that this leg number I want to try. This leg number I want to try on this day. Correct. First thing we have marked it. Second, we have to remove it from set. So set dot erase this index. Okay, we have to remove it from set. Also, we have to update this map. Okay, we will update this map as well. Map of range of I will become, now this location will become new location. Okay, and at the end we will return our array. I think this should work. Let's run it. Okay, it's not set, it's 0 index set. Our set name is 0 index, 0 IDX. Okay, yeah, all the test cases passed. Let's submit it and check. Oh, there is a wrong answer. Okay, what happens? So on day 1 we have a ran on 69, then we are not doing anything, then we are not doing anything, then we are not doing anything, then we will be doing the 69 ka, like we will be trying 69 because we want to avoid flood. Okay, so we will mark sure it hits 69. Okay, and these remains okay, -1, but they want this to be 1. Okay, so all of the answer where we can choose any leg to try. Okay, so we will mark it as 1. Okay, so if it is not found in the map, not here, so there is two condition, either it's non-zero, either it's 0. Correct. So we will make else. If range of I equal to 0, we will mark it as 1, and we will override whenever it comes. So there is no issue. Okay, answer of I equals 1. Let's try on this example. Let's add a case and let's run this. Now this test case is also passing. We are filling 1 wherever we don't want to do anything, and let's submit it. Yeah, it's accepted. I hope you found this problem interesting. Let's meet tomorrow. Happy coding. Bye.